Hello, everyone. Thanks for joining us today. I'm here with Hidden Path and High Voltage Studios. My name is David Yee. We're here to talk about growing cross-platform, talking about guys who have been in development for a long time, working in AAA development, working on console games and high-end PC stuff, and mobile as well, but taking their games onto Gear VR and the experiences they've had with them. So quickly introducing High Voltage, we have Micah with us. We have Anthony with us as well. Big news from them today is Dragonfront went open beta, which is actually pretty exciting. So if you have your gear or your Rift with you, please go check it out. It's a ton of fun. It's amazing how fun it is to play a card game in VR and lose your time in there. We also have with us from Hidden Path, Jeff and Michael. Hidden Path has been working on Defense Grid for us, which we will at launch. Defense Grid is, I think, one of the most comfortable VR experiences we've had. We've seen playtimes in excess of over an hour of people in average playtime. They have a couple of mobile products that we're here to talk about, and their experiences is bringing their high-end titles into mobile. So first, gentlemen, I thought we would just start with why Gear VR. And Jeff, since you have a microphone, I'll start with you.
I think the thing that's really exciting about Gear VR, obviously, is what you guys even said in the keynote, which is getting VR out to a huge number of people. And if we as entertainers can entertain a large number of people, then we can show them the kinds of things that they can get access to in our products. And as entertainers, that's the way we think of ourselves. We want to create the very best possible products we can. And so we've been really fortunate to work with you guys on the Rift and try and make what we felt was, one of the most comfortable and fun games possible. And if we can find a way to bring that to that Gear VR platform, which has really different performance characteristics, really different, design of how the user interacts with it, then we feel like, we can reach more people and get that out there, and then they can say, okay, this is a great experience, I love this, but I might want to try the Rift version, and just kind of have that bridge up throughout all of VR.
Micah?
Yeah, I mean, to your point, the game that we're working on, Dragonfront, has a multiplayer capability, and so in order to get more users playing the game and just to generate more player pool, the Gear VR was definitely the choice for us in order to expand that.
Can you talk about the decision, did Dragonfront start as Rift? Does it start as Gear? And what it made the kind of transition over the most interesting?
Yeah, okay. So, I mean, we did start as a Rift title. I don't think we had a lot of intent, else I think things may have been designed a little differently, but we didn't have a lot of intent at the start to do Gear VR. So when we decided to do that, we really had to start looking at how we were going to transition that over, and that's everything from performance to controls to, yeah.
Absolutely. So talking about planning, the thing that's very important, the thing that changes almost immediately as soon as we start, but still essential to the development process. How did you guys plan to move kind of your Rift title over into Gear? I'll leave it open to anyone who wants to take it.
Yeah, we were pretty lucky. We were starting with Unreal, so it had gear capabilities. The big thing we knew we had to cut from 15. A game that was like 15 gigs down to somewhere in the 700 meg range. So that was part of our plan. Was let's just cut and cut and cut and see how far. We're not even going to see how far we have to go. We're going to see how far we can go, and if we get far enough, we'll try to bring it up. That was the plan. We never got it far enough down to start with. We also, there's some really nice tools out there now that helped with reducing content. I'm going to make a call out to Simply Gone, because if you're going from a PC title to something like Gear, automation in your LOD system is a must, unless you're floating in cache. I guess you can do something else. I'll let.
So for us, it was actually interesting because we had taken a PC title originally, which was Defense Grid 2, and brought it over to Rift, and that was already a pretty big deal to try to hit 90 hertz and make it VR, because you have a lot more pixel fill than you do on a regular game. And we probably did about a 10x performance speed up to get it really performant and behaving as we wanted to on Rift. And we feel really passionately about comfortable games, so we wanted to make sure that we hit the performance marks and that it was something that anybody could play and not and if it was their first experience in VR, that it would make them love VR and want to do more of it and not become one of those VR isn't for me people. So when we were first talking about bringing Defense Grid 2 to Gear, it was really interesting because we had already done this 10x speed up and we had gotten all of the low-hanging fruit, and suddenly we're looking at it and it's another 100x speed up. And at that point, we weren't even sure whether we could do it. So we started off actually by trying out tools like Simply Gone and just running it on our levels and see what would happen. We went through and basically looked at every aspect of the game design and said, can this be cut? Can this be simplified? It was also important to have as accessible a game as possible, which means have something that ran if you didn't have the controller, if all you have is the headset. And to do that, like we were already lucky because Defense Grid was a pretty minimal control game. And in this case, it was going through and saying, well, can we even make it lower? Can it just be a tap, a look and tap? And then we can do some complicated things for things that are lesser used, move things off the controller and into the environment and things like that. So we kind of deconstructed the game in preparation for it to go into Gear.
The other thing I just throw out there is in planning, and got to give Oculus credit as we talked about this project. As we talked about what we were going to do, we saw the list of unknowns, and we had some ideas of what we were going to do to tackle each of those unknowns, but they looked like they might be pretty time-consuming. And so we tried to be really conservative. This is going to take longer than we think to do this or do that, and some of these are unknowns. And as we get on the platform and we start using the different tools, trying to use Visual Studio with an Android platform, or do you use Android Studio, or some of these different things, the profilers that our team has access to are very different and perform very differently in the mobile world. Our top guys are going at it and they're going at full speed, but because these are not the tools they have used for many years, they've been on consoles, they've been on PCs, they definitely feel like they're kind of going at 2/3 speed, half speed sometimes. And that's something that really needed to be taken into account.
So let's talk about another one of those unknowns. I mean, Hidden Path has used many engines over the years. You've had experience working with a lot of different types. How did you choose what engine you wanted to use for your mobile product?
Well, for us, in this case, because we had a game that had been released on PC and then we did a VR version, we weren't going to rebuild the game. Like, that didn't seem like it was, for the type of timelines we were talking about, was very reasonable. We were working off a custom engine, and I don't know if, like, this was 5 years ago, or how long ago was DG2, like?
2014.
2014. Okay, so, no, the original. I don't know. It was a long time ago. And it was before Unreal and Unity have both come down in price and started to get very mature. And I don't think that we would do that again in the future. But because this game was based off our old engine, we were actually bringing our engine forward too, which meant that we had to deal with a lot of lower level things, I think, than a lot of people will have to.
So I think the question, I answered the wrong question. 2009, I think, is when we started working on this tech.
Okay.
And Unreal and Unity just weren't really great options at that time. Working on our own engine in this case, though, I think has given us some advantages. There are some features that are coming in Unreal, that are coming in Unity, but because we had access to the engine, we've actually already implemented them in this engine. Multi-view rendering, some faux foveated type stuff, some things that will be coming in those engines, and we would have to normally wait for those to come. Because we were in our own technology, in this particular case, on this early wave, I think that's actually helped us.
Anthony, what was your engine decision-making process like?
Well, we'd already invested a lot of time in making the Rift game on Unreal, so it was the engine part was pretty straightforward. Mm-hmm. Unfortunately, since we never truly planned to put it on Gear, that code, the Gear code, kind of rotted a little bit, and there's a lot of different. Microsoft compilers aren't necessarily standard compliant, so there was a lot of things that had to be rewritten just because it wouldn't compile on the GCC compilers that we weren't expecting. But if we look back at planning, I think Micah and his team did a lot of work in reducing. I think our original game had 400, 500, 600 draw calls, and on the Gear you're limited to 50 per eye. And if you play the two games, you'll see we did the very best we could as far as telling the player what to do. But there's a lot of things we removed. There's a lot of decisions we had to make as far as transferring. The board was a very fancy board that we had 3 or 4 draw calls per each square on the Rift version, because we did some special effects depending on where you were. The final game has 1 draw call. The Rift game, or the Gear game, actually has 1 draw call. So we made a much fancier shader that actually we moved some of the work over to the GPU. But that's the sacrifice we had to do for the number. What else did we do?
I mean, so it was interesting. Yeah, we had like 800 draw calls, and I didn't know what a draw call was, and I didn't really care. But when I was told that it had to get down to 50, I was like, okay, I guess I have to care now. What's a draw call? Went through the explanation of what they were, and essentially every number that was on every card, every icon, every unit, every visual effect, everything that was it was a draw call. And it's like, okay, well, how do we? I mean, I'm sure this is getting ahead of ourselves here because this is planning, but how do we reduce this down to 50 and still communicate everything to the player that we need to communicate? And so that was something that was a bit challenging, but I think we pulled it off.
No, I think you were great when it was so much fun having them come in and say, so the shield is a draw call, and the number on top of it is a draw call? Are you guys sure that this is, they'd question our draw call calculations on so much stuff, because and widgets were another thing that the UI team had to, because they were very happy just saying, hey, this is a widget, this is a widget, this is a widget. And they then had to go back and look at the UI and say, how can we combine things?
We actually ran into that on UI too. We were using Scaleform, and Scaleform with your game running it on Gear is not really that practical. So we ended up kind of redesigning and rebuilding the in-game HUD so that we had a lot more control over the efficiency of it.
Great. Well, I want to get into tech a little bit more, but before we do, just to touch on planning, Jeff, you mentioned that there were a lot of unknowns when you were looking at doing this project. Can we get specific and some examples of some of the unknowns you had and how that changed your schedule? What did you schedule for? Did you schedule time to figure out unknowns? Is it unique to going from console to Rift, or console to mobile, or is this something that happens only with VR?
So when we were doing the scheduling, we looked at a lot of the things like tools. We didn't know what it would take to compile on Android. We hadn't done Android development before. And we kind of came up with our normal production process is to come up with a min, an average, and a max for each tasks. And one of the big things about this project was the volatility was really high, because we didn't know whether our first thing we tried was going to work or if we'd have to iterate a lot. And so I think that those are the examples. Like going to Android in general, one of the unknowns that we didn't know that actually impacted us a lot was the iteration time is really, really slow. And it takes a long time, like where we're used to just building and running, and if you're in Unreal, you can just hit play again. Suddenly packaging off a build to the phone and sending it off adds 5 minutes to your loop. And as soon as you get to the point where somebody has to get up and go get a drink because they're waiting for a build, you've actually lost a lot of their flow. And that's kind of one of those unknowns that hit us across the board that we weren't aware of was just the time to take for that iteration.
The other thing I'll throw out there is we started out and we said, okay, we know what our min-spec PC is, and we kind of know what CPU and GPU it has. Let's look at the phones. And okay, they have these CPUs and GPUs, and let's look at some benchmarks. And okay, we kind of have, we didn't think it was going to be 100x, we thought it was going to be 20x. And 20x we thought we could do, right? And we had different reasons. But once you start learning about heat and transfer across the bus on a phone, and that you need to throttle the CPU and you need to throttle the GPU to have the phone not get super hot and not last. If you want it to last more than 5 minutes, you need to actually care about the phone's battery and its long-term performance. And we have a game where, if bringing Defense Grid to Gear VR, we want hour-long play sessions at least, right? A half hour to an hour. And so we need to make sure that that phone is continuing to operate in VR at 60 frames a second for that time. Those become new ways of looking at the delta that we had to accommodate for moving over to Gear VR.
Anthony, Micah, anything in the planning phase for you that changed or surprised you? Something that you set out to do that didn't become reality when you actually got to development?
I'm sure that there are,
and
I probably put them way behind me because it was some of it was very not pleasant. And we actually, you mentioned that there's, you're looking at the phones, and then you learn that there's, hey, we have a Samsung S6, we're set. Well, is that a European S6 or is that or S7? I forget which ones have
One
the
with the
different.
Snapdragon.
Yeah,
with the
yeah.
other.
I don't remember which one is which and then it's like, well, hey, we have an S6. We have an S6 Edge. Well, that's going to behave the same, right? And it turns out that no, they don't behave the same because primarily, like it was mentioned, heat was our major boogeyman through this entire project. We got performance up, and then we thought, hey, things are good. And then you notice that the game you can go for 20 minutes and the battery's done, or it overheats, right? And I'm thinking, hey, Micah, how long's the average play time here? And he's like, hey, a game lasts 12 minutes. Hey, we're good there, right? But no, the guys at Oculus said 20-minute playtime isn't acceptable. But as far as planning, I think it still goes back to we didn't appreciate how much we had to reduce the art, because I said something about Simplygon, but the artist did an amazing job of reducing the shaders. We removed reflection. We removed all the lighting. We removed, and made them just a very plain material. The artist did a great job of painting them and making them look nicer. And I think they were dying inside when they were doing that, because they had these awesome reflections on everything. And then so that was, I think that there was a lot more art involved. Even though I told when we were starting to plan this out, I said we have to plan for a lot of artwork. I think I missed that a little bit.
Yeah, go Michael.
Yeah, just as another thing, I actually think the rule of thumb for people with projects that are on Rift that they're looking to take to Gear is that when you're going through and prioritizing what you can cut, you should go really deep and be prepared for it. And the thing that kind of keeps your morale up during this whole thing is that you look at games on Gear in general and games on Rift, and there is a quality difference. And what you're going to compare against. We come from AAA background, so we tend to have really high standards when it comes to art and polish and what everything looks like. And you can actually have that same standard for your work on Gear, but it's still going to look very, very different from what that PC product is like, and it's okay. I guess that's the message.
I'll agree with that you're in two different mediums. The game looks amazing on Gear, but if you were to put them side by side, you would immediately notice one looks like a game from 10 years ago, a console from 10 years ago. But if you think about that, you're now holding something in your hand that is more performant than a 360 in some aspects, right? Other than heat. So it still is an amazing job, and it shows that these senior artists can call back to their old skills and make it still look great in whatever medium that's tossed to them.
Yeah, we hear people go around saying, oh, the phones are so powerful, they're going to replace PCs, they're going to replace consoles. And then you start having to deal with the heat and the bus speeds and just different parts of the computing platform that we don't normally deal with on a PC or on a console. And you start realizing that, no, it's a very different platform. It is extremely special that everyone has one and that it's super mobile, but it's a very different platform, and you need to look at it as such.
I think that Abrash's point earlier really resonated with me when he was saying, like, no matter where things are, you're always like, if it was just a little faster, we wouldn't have to deal with this.
So great historical examples of how you guys got to the projects you're dealing with. I want to jump back to technology now, and not specifically on the choices that you've made for your projects, but you were giving advice to teams that are going to go from Rift to Gear. How would you advise them to choose their engine? What do you think are the pros and cons of the ones that are out there?
Yeah, so for me, in our experience between Unity and Unreal, actually, given that those are the two main engine choices now, I would say that the biggest thing we run into is that Unity is really, really fast to prototype on, especially for programming. And Unreal is much faster to prototype on for art and design and puts more burden on engineering. And we found ways to mitigate that, but in general, that has led us to doing a lot of interaction and engineering type prototypes in Unity. And then for actually doing our games, we tend to move to Unreal because the art and design teams are a lot more comfortable there.
In content creation. And just the one other thing there is that as we're learning the power of blueprints as well, we're able to iterate a little faster on Unreal. I think the Unreal announcement that you guys did is awesome. I think there is a larger curve of learning to be done to become really good at fast prototyping with blueprints, but I think it pays off when you get there. Pretty much everything we see that Epic is doing, we're getting more and more impressed with. Unity is good. There's nothing bad about it, but we're just getting really super impressed with what we're seeing from Unreal. Yeah, on the tools.
And I'll go with them that I think Unreal makes the artists happier, at least for the ones in our company. But there's more to the technology as far as shipping this game. I highly recommend that if you haven't done a Gear game or you haven't done an Android game, you get comfortable with the tool set before you start estimating how long things are going to take, because there are quite a few GPU analyzers and CPU analyzers that are told to be able to work, and it takes a little bit of chicken blood to
It's
make.
just like Pix, only on the Android phone, right? No, it's not. No, it is not.
And you'll be talking with Qualcomm engineers, and they'll say, "Hey, it just fires right up and it works without setup. I just happily go along." I don't know what phones they're using, but they're not commercially available phones. So if you are looking at doing a Gear game, and the tools are good once you figure out how to. Once you figure out how to use them, there are some really good tools out there. But you're going to spend the people are used to using the PS4 and some of the Windows tools. It's going to take a while to get used to what you have here.
Our experience is that there are exceptional CPU tools out there, and where we're still looking for the right tools is on the GPU side. That seems to be much more challenging. But I know our guys, they swear by Profiler.
Yeah.
They really like that one as a CPU tool.
Awesome. Are there any other technology tips and tricks that you feel like you should share with the audience as far as going from developing on mobile, or again, take away from Rift to Gear?
I mean, I think you could do an entire talk on performance tips, like using texture atlasing, reducing your batch calls, tricks for reducing particle performance. Like, for example, there's a lot of things where we didn't want to go through and recreate all of the art, so we started off with rules of thumb like increase the alpha on all the particles and decrease the count by a fixed amount, and then go through and fix the ones that are broken. Increase the opacity. I said one or the other, one minus. The other thing, like one of the techniques that we found that was actually really cool that we discovered and is the direction that we're moving for our game, is we went through and realized that 99% of our scene is static. We have the dynamic elements like the aliens walking through and the towers firing, and the rest is static. And there's actually, if you go and look at the things that Gear does really well, you see all the 360 videos and the 360 movies. And that's actually deals with really high resolution, good looking content very well. And so we actually came up with a technique that we'd actually go through our Rift, our PC renderer, render the entire scene to a skybox and capture the depth as well. And then when we go to the phone, we play it back like a 360 video and use that depth to integrate the scene elements with it and kind of counter some of the distortion. And we actually think that'll be the path that we take. And it's great because it lets us keep a huge amount of the lighting and visual fidelity of the assets.
High Voltage, do you think you would have made the same engine choice if you had to do it again, knowing you were going to go multi-platform or cross-platform from the beginning?
Yes. The big, excuse me, the one thing we would take away is, and we're actually, is think about the Gear the whole time. Like I said earlier, we didn't care about Gear when we first started. Some of those code paths got a little crufty. They didn't work so well. So if you do think you're going to do both, then go ahead and have a build PC sit there and constantly run integration tests all the time. It doesn't cost anything, and as soon as you get that the bit of code that won't work on one or someone breaks something, it'll call it out. The other thing is that if the art team knows and the design team knows that it is going to go to Gear, they can start planning from day one on their draw counts and how they're going to make it look right on the different platforms. I think that our UI is very complicated, not very complicated. It's very deep in Dragonfront when you want to, because you're making decks, right? And I think if we had more time, we could have made it simpler on both platforms. If we could have done something that would speak to the player.
Yeah, UI in general has this kind of push-pull between easy to create and easy to render, and they often are not the same.
Oh, very much true. Like I said, the artists used a lot of widgets because they had fun, you know, hey, I'm going to put a widget over here and it's going to come flying in over here. And that is, now that you mentioned that, that is one thing that I think Unreal does not do very well. Their widget system is not that good for gear, and they actually, what they're doing is the widgets are rendering to a texture every frame. And so every single widget renders to a texture, and then you actually render it to the screen. And then what we added was only when it's animating, the only time that when the widgets are animating, then we're rendering to a texture. But once it becomes static, then we use the last texture that was rendered as the now de facto texture. And that was a huge improvement, because we had somewhere in the neighborhood of, I think we had, when we first got it up and running, and the first time we had something visible, we had 70 millisecond frame time. And we had our graphics engineers looking at that thinking, no, it wasn't 70, it was 140 milliseconds. And there's no way they're going to get that down to 16. And it turned out with just this one change to the widgets, they got back somewhere in the neighborhood of 80 milliseconds. Wow. And you don't get that very often.
No. One thing we're finding on some products where we're using Unreal, and we're super happy with it, is that we're trying to be really careful about doing as much of our game and code kind of separate from the engine, whether it's in blueprints or in other areas, so that we can continue to take the updates, because these engines are changing so much right now, and so many new cool performance or ability to change how the UI is done. All these features are coming in practically every month. And if you do make some significant changes to the engine, it becomes really painful to take updates. So as you're planning, or as you're working on the technology, really thinking about your architecture and where the game code's going to live, and how you're going to be able to easily or not easily continue to take updates, I think is actually a really big part of planning for the project too.
And we actually set it up in Subversion, or whatever your source control is, our root was root Unreal. So anytime there was a new Unreal that came out, we would put it right in there, and then we could see the difference. We could make a patch between old Unreal and this Unreal, and then propagate that patch to our game. And it prevented that case of, hey, is this a change that we made, or was this a change that they made? Even though you're supposed to put, that whole thing, you're supposed to put comments whenever you change someone else's code and say, hey, this is one of ours, don't blow it away when you update the engine. Sometimes those don't get made for whatever reason, right?
One of my favorite, not favorite stories about the perf, especially with your two projects, was debug mode, and kind of how we learned about that. And could one of you tell the story about kind of that journey on that tech call we had?
Were you on it also?
I was not on it, but I heard about it.
So we spent about a month trying to counter heat. We had gotten performance way, way down. We were happy with our performance. But then what happens is when the heat kicks up, the throttling hits you, and then your performance drops, and it's an unpleasant experience. And we'd been optimizing everything and trying everything we could figure out how to make the heat better. We even went down to, there's 4 settings for the CPU and GPU that you can set to, and we went down to the minimum one to see if that made any difference. And then we had scheduled a call, and nothing made a difference. And I can't remember who the...
We had people telling us that a phone won't overheat at 1.1.
Yes, that's the same thing.
It's like, you're the only company in the world that has a phone that's overheating at 1.1. And we're like, it's setting at 1.1, and it's no problem.
We had a dev call with somebody at Chris Pruitt, at Oculus, and as a throwaway comment, he said, "Oh yeah, in developer mode, we found there's some developers who had spent 2 months and didn't realize that turned off all the throttling on your phone, and so that it would always run at max speed and overheat." And we're like, "What? What? What'd you just say?" And it turns out we got added to that list. And as soon as we started having our testers and did performance testing while not in developer mode, we actually got much better results and were able to start seeing what the effective things were.
I mean, that was very frustrating. We were sending builds to Chris Pruitt, who was very helpful in trying to get, he works for Oculus, and he was saying, he was trying to give us pointers on how to get the performance down, and then we'd give him a build, and he said, yeah, it ran for an hour. And no, it's running for 15 minutes before it overheats. And then, that was very frustrating time.
So then the question becomes, well, what does dev mode do? Why is there this switch in the phone, and why do all of us who've had to make, console games and put them on, dev consoles instead of retail consoles, what is this for? And it turns out dev mode is just for USB debugging. If you need to plug in a cable and plug in USB and you want to debug in real time while you're running the phone, you turn on dev mode. All other times, turn it off.
Turn it off. Even your test department. That was, our testers were doing it. There was another test group that had it on. And so across the board, we're all seeing 15 minutes before it would overheat, except for Chris Pruitt. He could run for an hour.
Just on tools too, because it made me think of it. One of the things to be aware of is if you're debugging through the USB cable, we would often see 30 seconds to step to the next line. So you actually get really good at finding ways to debug through logs and things like that, because while you can step-by-step debug and do breakpoints.
Which you're used to.
Yeah, what you're used to. For us, we actually had pretty poor results trying to do that.
There was a good bit of printf debugging.
It's great examples, guys. How do you, besides talking to Chris Pruitt and getting on call schedules, how do you find this kind of stuff out? What community have you reached out to? How do you determine where these things are? Or is it really trial and error and just applying old school dev practices to new school technology?
For us, I think it's the trial and error. We would look on a lot of the boards, but especially because we have a custom engine, it's harder to get support because the people who are doing the same things as us are working at the engine teams, and they're usually talking directly with their developers. We had a huge amount of background knowledge in optimizing for consoles and PC, and so I think that we went out and we just kept trying to search for tools and work with Oculus to figure out what the right tools were. And the Profiler worked really well for our CPU, and then the native Qualcomm and such for GPU tools. One of the things too that I lost my train of thought. I'll come back to it.
I'll just throw out that one of the things that we really appreciate is Tamara.
She's here.
Hi, Tamara. We appreciate you. She sends out to all the Gear VR developers who are connected the notes and has this monthly meeting, and that information is one of the most valuable things. And if you're not on that mailing list or you're not on those calls, you find out how you can be if you're working on Gear VR, because again, a lot of your previous development experience is super useful, and then there are holes, and there are big holes because Android is different, and it was made for different reasons, and we're all trying to bring these great games onto them, but that wasn't their native reason for being, and they provide so much extra information on, how you can do what you need to do.
Yeah, that monthly call you did was very helpful, and I don't think I asked a single question, but I listened to every one of them because there's a lot of people who knew a lot that I didn't know. And I agree with you that our company's done a lot of ports in the past, so we're very efficient at taking something that was on the 360 and putting it down to the PS2 or doing those type of projects, and that's what our team did. And we found there was a lot of blueprint things that needed to be cleaned up. And the nice things of that, those actually went back to the Rift version. So even though the Rift was mostly running at 90, unless you filled up the entire board and you put a spell on everything, it would run at 90 and it was great. But we found additional little bits and pieces doing that port to Gear. I don't think you kind of hinted at it, but opacity is something to get rid of. Get as much opacity, get rid of all the alpha that you can in your game. If you have any alpha, have it just on some particles, but if you can, get it out of your game.
Alpha's your enemy.
Yeah, we actually found that we could push even like 2 million verts if their shaders were simple, but fill rate was what took most of the time for us. So we've actually focused most of our graphics performance around minimizing fill rate, and that was a big thing.
Dragonfronts has, I think, 600,000
Okay.
on a Gear. So on your little phone, we're pushing 600,000 verts a frame.
So you focused on, it was fill for you as well. Yeah. I remember what I was going to say as well too, which is our default, because it's so much easier, is to iterate on Rift. And it's VR, and we can test everything in there. And it was actually interesting going to phone. We were so proud of ourselves because we got our entire game down to 0.2 milliseconds, our frame time on Rift. And we're like, that should work great. We should just be able to pop that over, and we're going to be at like 90 frames a second on gear.
We thought we were so far.
Yeah, we thought we were really far ahead. And when we took our 0.2 millisecond frame time over to gear, it was 30 milliseconds. And that was one of those times where like, wow, we thought we did well and we have to go lower. And that's probably the biggest lesson, is that no matter how fast you think you're going to be, if you're taking a PC game, you got to cut out everything. You have to plan to cut out anything you can possibly cut out to get it down to the core experience of what you want to show people.
Well, we can talk about some of these things when we get to the game. It's going to take some of Micah's thunder, but
I can't wait.
Well, you guys.
I can't wait to take it, but I'll take it next when we're talking about it.
Well, Dragonfront started on Rift and went to Gear, and Jeff, I know you guys have used Rift in the past to prototype, even using DK2 to prototype before for mobile and other things. Do you guys find there are other benefits? We talked about something you took from Gear and went back to Rift. Do you find that working on both platforms helps you in other ways?
I think that the really awesome thing is for us as PC developers, MinSys is like what drives your market. And the really cool thing is as we have done all of these things and have like this functional mobile game that represented the PC, like I think we can make our PC games now run on like 486s and it'd still be good. And so the performance stuff really lets you take it back, especially there's a lot of cases where you can be a little bit sloppy on Rift, and you're like, well, we dropped to 80 frames a second for that one time, and certainly as we're going through and doing this, we're realizing that we actually can make tweaks that are visually imperceptible that keep us rock solid all the time. Like, if you can run on Gear, then you will be absolutely fine on Rift.
It definitely keeps you honest as far as your the visual effects. Do you really need this visual effect here? And the art team would evaluate, and then there's visual effects that came back onto the Rift because again there was no different. Maybe an artist sitting in a dark room, who crafted it, he would be able to notice the difference but the average user, they wouldn't notice it, and that's what we're aiming for, is the average user.
While looking at your character that's 1 inch on the screen in full screen, yeah.
Awesome. Micah, let's talk about some game stuff. So we learned about draw calls.
Right. Well, and so I want to go back to that for a second because you'll see here, this is the Rift version. Yeah, it's right up here.
It's not as bright on that screen, actually.
So this is the Rift version, and you'll notice that some of the spaces have like 4 units on it. Well, that's 4 draw calls. And so, when they told me I had to get rid of some of these, I'm like, all right, well, we'll put 1 unit on a space. But as a designer, I then played the game, and even if I filled the board, we got little rats. You could see these guys are human size; they're kind of small. And so the board just wasn't as impressive anymore. And so I'm looking at the game, and I'm like, there's something missing. I know we changed all these guys to be single units instead of 4 or 2. But we need to do something to make it more impressive. And really, all we did was we just scaled things up. And once we got the units to be scaled up, it felt more like miniatures, like little figures and stuff. And I mean, in my opinion, some people were actually thinking about bringing that to the Rift version. I personally like both versions. I like the Gear VR version because they do feel like they feel like toys. I like the Rift version because you can see more of a sense of scale and between the different units. Honestly, I want to see a giant as a giant, right? And I want to see rats as a little rat. But it's cool for both, I think. One of the other things that we did to get rid of draw calls that I think also kind of was aided by our sense of trying to change the control scheme was anytime you had your hand open, all those cards would appear. All the numbers on all the cards and all the icons for the power and mana and health were all there, and it was just so many draw calls that when you had a full board, it was just too many. And we're like, well, how are we going to do this? You can't have your hand open at the same time as you're looking at the board. And people are like, well, we'll just put you in a different dimension when you're looking at your hand. And I'm like, no, you got it. Everything's got to be there. So, and then the controls of opening and closing your hand on the Rift got to be a little tedious. And so we decided to go back to an idea that I think somebody at Oculus had. It was Mike or Ruben or somebody. And the idea was to actually just kind of look up a little bit. It would hide the board, and it would display your hand. And so just that little subtlety kind of remedied an issue that we had with controls, and at the same time got rid of all the draw calls on the board while your hand was open. So it was a neat little design decision that we made. I think that saved us a lot in the end.
What about positional? I mean, because that's something that we have with Rift, but you're not having in Gear.
Yeah, so luckily for us, we're kind of in a static position, but there was a couple items that did come up. As you can see, we have all these units on the board. Some of them are giants, and when we were working in the Rift, some of the giants would obscure the units on the other side of them. It would obscure maybe their power icon or their health, but it was okay because you can just kind of look around them, and we thought that was part of the experience, actually being able to look around the board at your little characters. But we couldn't do that in the Gear VR, and so part of it was, does that even matter? I don't know. I think you still need to see those numbers. I think you still need to see the characters that are behind the giant units. So we're working on a system right now where it kind of dithers them out, and you should be able to see past them. But really, nothing else came up. I mean, we got lucky just in the fact that we're at a static position for the game.
Just gonna say, with Defense Grid, we had full head movement in the Rift. We have full head movement in the Rift, and being able to zoom in close down to towers. And those were some of the things we just said, okay, we're not even going to try and do that on Gear. We're going to pick a static place and check the game out. And we did a lot of evaluation of, can I control it from this place? And it's worked out really, really well. So we're really excited about being able to just embrace what that platform is, with being able to look around but still be able to control the play field.
And just as an add-on on that, for us actually, the fact that you have a static position on the Gear turned into a strength, because the 360, the whole process of taking the entire level and rendering it to a kind of like a 3D skybox was possible because you didn't move your position. So it turns from something that was a weakness into something that actually let us have very high fidelity and keep performance.
And just to add to that, I think Michael and some of our graphics programmers did this amazing work, because if you ever play with omnidirectional stereo, you have some real weirdnesses at the nadir and zenith. You have some real swimming and pixel movement that you'll see sometimes in certain videos, and then trying to match real-time 3D objects to that. There was a bunch of really clever techniques for error detection and matching, so that all of the real-time stuff was completely seamless with the 3D skybox with depth, such that the skybox would even occlude things, which was kind of amazing. And it just really allowed us to take something that was PC visual quality and place it unchanged on the mobile device. And I think it's a really exciting technology that's going to enable a lot of opportunities. And you guys even believe that when you do get some head movement on these, that we can still handle that. And that's going to be pretty cool.
So for high voltage, I mean, Dragonfront, you can cross-platform play Gear versus Rift, and it's seamless. Did you find that you didn't really lose anything from a design perspective? Is the game mostly the same, and it's only UI and UX you had to deal with?
Well, if you're playing cross-platform, I think at this point, you can't tell you're playing somebody on the Gear. You can't tell you're playing somebody on the Rift. Everything it all feels the same. All the design decisions that we made were to keep it fair to both players. I think really the only thing that we ended up working on was communicating certain things. We used a lot of persistent visual effects to show that this unit is buffed or debuffed in some way, and I think what we ended up doing was putting an icon above them that was part of a gaze. When you looked at them, the icon would appear, and so you can see what the buffs and debuffs were. And so really the only caveat to the Gear version is you can't just look at the board and see who's poisoned and who's not, right? But you would have to look at each individual unit. But at the same time, I think both players have the same advantage, and that's kind of what we were shooting for.
I guess one of the nicer parts of the heat problem we had is that we did cut a lot from the Rift game that we're actually able to trying to put back into the game now, because one of the big problems that he mentioned is in the Gear game. In the Rift game, you can see everything. You see all their powers, you see their buffs, but in the Gear game, it's because of draw calls, it's whatever unit you're looking at is the unit that you see the strength of, and then you have to look at the unit you're going to attack. But luckily, because we have some headroom now because of the work that we did, we're looking at trying to make changes to that so that make the games more balanced. But it is a great experience. You can do VoIP across from Gear to Rift. The little mask that actually follows your movement, that works for both sides. So you won't know that you're playing someone who's on Gear or if they're on Rift.
Fantastic. Well, thanks guys for joining us today. I wanted to quickly get to Q&A. That's my favorite part of these things. So if we can, we'll have to take questions for you. Good?
Those are some powerful lights.
Yes.
They are.
Is there anybody left in here?
Hi, I've got questions regarding networking for cross-platform support. Did you run into any issues when someone's on the Gear and they may not actually be on a Wi-Fi network, didn't have a strong connection? Like, how did you handle that with still keeping that level of fidelity and just gameplay?
Sure. The biggest problem that we're seeing even now is VoIP. So if you're not on a good connection, we're looking at eliminating the voice. The head tracking is only about 2K per second. So that's, unless you have absolutely just horrible internet connection, you should have no problem doing that. And then the gameplay is you're really just passing a turn for all intents and purposes. So that's a very small bit. So because of we're not doing a lot of the prediction type work that you'd see in a shooter, we do have problems right now because of VoIP, and we're looking at preventing VoIP. Or you can say, hey, I do want, even though I know I might have some bad experience, go ahead and let me talk to the guy before it starts getting choppy and we have to stop. But that's about the only thing we came up against. The Oculus team, the matchmaking worked very well. Once they have a grouping that you just say, hey, this product and this product are going to play together. We didn't talk much about it, but I'll go into how great the ecosystem is that the two games, I'll call them two games, but they're the Gear and the Rift, they share the same in-app purchase. They're the same person. If you have an account on one, you can take it on your commute to work, and then when you get home, you can jump on the Rift and you'll still have the same cards, you'll have the same in-app purchases. Everything is the same across both games. So you can jump from one to the other with no problem.
Yeah, we've been really impressed with the libraries available to us from the Oculus system. It's been pretty impressive.
I can't see any ones there, so are there more questions? Fantastic, gentlemen. Thank you so much.
Thank you.